you just see this hardware component. By using this, we can implement add operation, subtraction, increment and decrement. First we'll see how the add operation is implemented, how you will get the add operation or add micro operation from the given logic circuit, given logic, arithmetic logic circuit, right? So here what we are considering is what, one second. Let us see how this act like a I'll tell you how this logic circuit acts like an increment operation. So based on the selection values, it will act like a different it will act like a different, or it will give you different arithmetic micro operation. So when you see this logic circuit, we are having a 4x1 multiplexer. That means it should have 4 inputs and 2 outputs. Let us see what are the 4 inputs of the multiplexer. The 0th input of the multiplexer is connected to the all the 0th input line of all the multiplexer is connected to the registered bits of B. One input of full adder is connected with registered bits of A, and the Z is connected to the registered bits of B. So this multiplexer is connected with B0. Here it is connected with B1, B2 and B3. First line of the multiplexer is connected with the complement of the registered bits B. First line is connected with complement of registered bits B. So first line here it is connected with B dash, B0 dash. The first line of this multiplexer is connected with B1 complement. First line here it is connected with B2 complement, and this first line is connected with B2, B3 complement. 0th line is given as a and the first input is the complement of the registered bits B. Now second line, all the of these are connected to the input 0 or given with input 0. Similarly, third input line of the multiplexer is connected with the input value 1. 0 is the register bits of B. First line is complemented bits of register. Second line is connected to 0 and third line is connected to 1. Lines you should have. The number of selection lines for 4x1 multiplexer should be S2. Those are S1 and S0. Assume the selection lines are S1 and S0. Right? Now, based on the combination of different combination of these selection lines, this circuit will act or it will perform a different arithmetic micro operation. Now see, assume that the value of S1 is equal to 1, S0 is equal to 0. Whenever S1 and S0 is 1 and 0, then which line of the multiplexer is to be selected? The corresponding decimal value for binary value 10 is 2. The corresponding decimal value for 10 is 2. Therefore, second line from the multiplexer should be selected as a output. What is the second line? Here, when you see here, the second line of the multiplexer is connected to the output to the value 0. Therefore, the output of these multiplexers, output of all these multiplexer value will be 0, 0, 0, 0 and 0. I already told you that one input of the final, full adder is the direct input, that is registered bits of A. Another input is the output of the multiplexer, which is Y. So here, by choosing the selection values as 1 and 0, we got the output of the multiplexer as 0. The output of the multiplexer is 0. That means a plus 0, and if your Cn, what is the output function? The output function, the formula to get a particular micro operation is d equal to a plus y plus Cn. So here d equal to a plus y it is 0 based on the selection values, plus if you choose Cn, the carry input as 1. So if it is 1, then you will get it as d equal to a plus 0 plus 1. D equal to a plus 0 plus 1, which is equivalent to a plus 1. A plus 1 means what? Adding 1 to the content of register A, which is equivalent to increment operation. If you add a 1 to the content of the register, we'll call it as increment operation, right? So when you select S1 as 0, as 1 and 0, and Cin as 1, then the given circuit will act like a increment operator, increment circuit. Next, we'll see how this acts like a decrement operation. Before we see this, first we should know how to perform a decrement operation. How to perform a decrement operation? Increment means adding a 1 to the content of A. In the same way, decrement is subtracting a 1 from the content of A. Subtracting a 1 from the content of A. First, we'll see how this decrement operation is performed theoretically. How to do this decrement operation theoretically, we'll see first. Right? So, content of A is 1110, and you need to decrement or you need to subtract a 1 from this content. So, in our digital circuits, always the subtraction is done by using the complements and addition. Subtraction is not done directly by using the complement and addition. How to perform A minus B? A minus B is indirectly equivalent to A plus B complement plus 1. What is B complement plus 1? B complement is 1's complement. B's complement is the 1's complement of B. To the 1's complement, if you add a 1, it will give you a 2's complement, right? So A minus B is implemented as an addition, which is equal to A plus B complement plus 1. So here this decrement is also performed by using that only. So what is to be subtracted? You need to subtract a 1, right? How to write this one? You can also write this one as 3 zeros 1. Why? Because you are implementing this with a register containing 4 bits, right? Therefore, I am writing this single one as a 4-bit data as 000 followed by 1. Now, what is the first step? Whatever the data is to be subtracted, you need to get the 1's complement for this data. Then you need to get the 2's complement. That 2's complement should be added to the value of A. That is the process of subtraction using addition and complement. What is the 1's complement of 3 zeros and 1? 1's complement is simple. Just inverting the bits. That means in place of 0, it will get 1. In place of 1, we'll get 0. So 1's complement of 1110 is, 3001 is 3110. How to get this 2's complement? To this 1's complement, you need to add a 1. You already know how to perform a binary addition. 0 plus 1 is 1, 1, 1, 1, 1, 1, 1, right? So, to this, the 2's complement of 0001 is all 4 ones. That means, to get the subtraction, what you need to do? This is the content of A, and to this content of A, you should add 4 ones, which will give you a decrement operation. So, how to perform this addition? 1 plus 1 will give you a sum of 0 and a carry of 1. Next, 1 plus 0 is 1, and 1 plus 1 will give you a sum of 0 and a carry of 1. 1 plus 1 is 0. It will give you a carry of 1. and that 0 plus 1 is 1. Next, here also 1 plus 1 will give you a sum of 0 and it will give you a carry of 1. 0 plus 1 will give you a carry. 0 plus 1 will give you a sum of 1. Therefore, when you add these two bits, you are getting 1100, and this needs to be discarded. When you are performing according to this rule of this decrement operation, when you are performing this subtraction, whatever you are getting, whatever the overflow value you are getting, that can be discarded. This overflow value can be discarded. So the subtracted value is, the result of the subtraction is 1100. Right. So when you are implementing this decrement operation as a subtraction to the content of A, what you are adding? To the content of A, you are adding all ones. If the size of this register is 5 bits, you need to add 5 ones. If the size of the register is 6 bits, you need to add 6 bits. Like that, to implement a decrement operation, you need to add a 1 at every bit of the register A. Let's see that how that will be implemented. Right. So, what is the formula to get this different mathematical micro operation? It is D equal to A plus Y plus C N. A plus Y plus C N. Right. Now, so to get this arithmetic operation, what you are doing to get this decrement operation, how you are performing? To the content of A, you need to add, to the content of A, you need to add 4 ones. So, D equal to A plus, in place of Y, you should have 4 ones, and in place of Cn, you should have a 0. A plus 4 ones plus 0. Right? That is a way to implement a decrement operation. Now, here value of Y. Y is the output of the multiplexer. Now see this. See the hardware diagram. So A plus Y plus Cn. So your Cn should be equivalent to 0. To have this circuit like a decrement operator, and your Y should be equivalent to 4 ones. That means Y0 should be equal to 1. Y1 should be equal to 1, Y2 1 and Y3 1. What is this Y? Y is the output of this multiplexer. So in place of this 0, you should have the value as 1. How you will get this? Is connected to 1. The third input line of the multiplexer is to that. If you select the third input line, then as your output, you will get the of Y1. So third line as. So which input line is selected is always based on the selection line. Here you need to select the third line as your input line, because you should get Y equal to 1 and your third input line is connected to 1. To select this third input line, what should be the value of S1 and S0? To get this third input line, so you should have the value of S1, S1 and 1. What is that corresponding decimal? The corresponding value is 3. 1 and 1. 1 decimal value is 3. Therefore, if the values of S1 equal to 1, S0 equal to 0, then you can have this third line and will get Y as all the multiplexer. So in this way you can implement just like a operator. If you want your circuit to act like an increment operator, be equivalent to 0. If you want to act like a decrement, 1. If you to be 1, your third values should do. If you want your y to be equal to 0, then you can select the values as 1, 0. The selection values can be 1, 0 and Cn should be equivalent to 1. This is the way to implement increment operation and decrement operation. Like that, by selecting different values for the selection lines, by selecting different values for the selection lines and a code, you can have different micro operation, different micro operation. Let us see this. So selection use and C input value 0, then the just equivalent to 2 equal to A plus B if the operation. If the values of selection lines carry input something like this, 00, 00, selection lines is 1, and if y equal to, it acts like a subtractor. Sorry, it acts like with the combination is sub with borrow. A plus B complement is known as subtract with borrow. Excuse me. Similarly, if the values are like this 011B, then it equal B, which is subtract operation. Like this, based on the different combination of the selection lines and carry input as well as your y input, the logic circuit will act like a different arithmetic operation, will give you different arithmetic operation, right? So using this single circuit, instead of having a separate circuit for individual micro operation, you can have a single circuit. So by changing the values, you will get your required micro operation. So with this, all your arithmetic micro operations were completed. We have already told you that arithmetic micro operations are how many categories of arithmetic micro operations you have? 4 categories. One register transition operation and shift micro operation. Register transfer is some just moving the content from one register to another register. They will not change the content of the register. Now, and we have seen arithmetic operation, how to implement add operation, how to implement increment, and we have seen a single circuit to implement all the arithmetic operations. So with these arithmetic operations were completed. Next, we want to logic operations. Let me share the screen. Wait. Yes, ma. As the time is 5 o'clock, if you have any doubts, you just ask me the doubts. In the next class, I'll start logic micro operation. Because by 5, I'll start the quiz. In the last class, we didn't have the quiz. So today we'll have a quiz. We'll have quiz section. So yeah, I'll give to post your doubts. You just ask me the doubts. I'll be here to clear. Okay. My internet connection is good, ma. The signals are very good. Check the internet connection from your side also. No dots? Last slide. What is this? This one. So this is what are the selection values and what should be the value of C and declare micro operation. This you need to remember, ma. If you want, you just apply these values in the arithmetic circuit and check whether you are getting the same micro operation or not, whether you are getting the same output or not. Just apply the values of 0. See here, when the what we call selection values are 0 and carry input is 0, then micro operation or not. Let us see. Go to the slide. What should be the value of selection lines? S1 and S0 both should be equal to 0 and your Cn should also be equivalent to 0. When S selection values are 0, which input line you need to select? You need to select this 0th input line is connected to the registered bits of B. B0, B1, B2. So what will be the output by B0 from first multiplexer, B1 from the next one, B2 from this multiplexer and B3 from the last multiplexer. As your Cn is 0, what will be the output from this full adder? One input given to this full adder is E0. Second input is the output of the multiplexer, which is B0. So A0 plus B0 plus carry input, which is 0. Therefore, you can write it as A plus B, which is equivalent to add micro operation. Therefore, it acts like a add micro operation. That is this table mark. So, different selection lines and different value of B will result in micro operations. Any other doubts? Wait, I'll just brief what we have discussed today. Today we have discussed the increment operator as well as decrement operation and a combined circuit for implementing all the arithmetic operation. So, increment means just adding a 1 to value 1 is our content as 1101. To this, if you add them, see whatever the sum you will get, that will be your increment operation. 1 plus 1 will always give a sum of 0 and a carry of 1. Just check the rules of the binary addition. There you will find this. 1 plus 1 will give you a sum of 0 and a carry of 1. Next, 1 plus 0 will give you a sum of 1 and a carry of 0. 0 plus 1 will give a sum of 1, carry of 0. 0 plus 1 will give a sum of 1 and carry of 0. Now we'll see how to implement this using the hardware components, right? No. How many bits? If you full adder requires registered bits of B output. When you are performing an increment operation, you can add a 1 to the content of one register only. Therefore, how many you are adding? How many bits you are adding? You are just adding only 2 bits at a time. Only 2 bits can be added. Therefore, instead of a full adder, you can use a half adder, which will take 2 inputs and it will give you 2 outputs, and one half adder be given as an input to the next full adder. Sorry, next half adder. Where consider size 4 bit, so I am taking 4 half adders. And one more thing is, when you are performing this in already one SBT register, you also need to add 1 to the LSB bit of your register. That is fixed. This one is always fixed. Whatever may be the content of the register, you are adding a 1 at the LSB position. The second input for all is the registered bits, that is A0 to A3. And for the first half adder, the fixed fixed input is 1. This 1 is always fixed. The content may be changed, but this 1 will be 6. So when you add this A0 plus 1, it will give you two outputs. One is the sum and the second one is carry. Where you are giving this carry? See this. Whatever the carry is generated after adding these two LSB bits, carry next bits, right? So here whatever the carry is generated when I put to the next half adder. So A1 plus the previous carry, which again will give two outputs, S1 and a carry. Again give this carry as an input to the next half. So this will be of the register done. So if the size of the register is n, then you require n half adders to perform this. Next decrement out. Before we see this decrement operation, here I am going to use a logic circuit which we known as arithmetic circuit, which is responsible to perform all the arithmetic operation. Whatever the arithmetic operations we have, a single circuit is sufficient. Instead of having a single for each and every micro operation implementation, let us have a one combined logic circuit which will perform all the arithmetic operation. We'll call it as arithmetic. Arithmetic ladders on number of bits in the register. If you have 4 bits, you require 4 full adders and 4 multiplexers as size of 4 by 1. And here your size of the multiplexer is 4 by 1. That means 4 inputs and it will give 1 output. And the inputs of these multiplexers are connected like this. 0th line is connected to the register. Multiplexer is connected to B0, B1, B2 and B3, which are the data of registered B. Similarly, first line is connected to complemented bits of the registered B, and second line is, and the next line is connected to 0, and the last line is connected to 1. Last line is connected to 1. Based on the selection values and C in, that is the carry input, it will act like a different arithmetic operator. The circuit will act like a different arithmetic operator, right? Now we'll see. So what is the formula used which arithmetic operation is performed? D equal to A plus Y plus Cn. D equal to A plus Y plus Cn. What is D? D is the arithmetic micro operation. A is the registered bits. Y is the output of the multiplexer. Cin is the carry input. A is the registered bits of A. Y is the multiplexer. So, let us see how this increment operation is performed. So, to perform this increment operation, the selection values should be equivalent to 1 and 0. Whenever the selection values are 1 and 0, the corresponding decimal value is equivalent to 2. So, the second input line from the multiplexer is to be chosen. As your second input line is connected to the bit 0, second input line is connected to the bit 0, will be the output of all the multiplexer. So the value of Y is equivalent to 0, and if your Cn 1, then what is the output? D equal to A plus 0 plus 1, which is equivalent to A plus 1. A plus 1 means it is a increment operation. Next, let us see decrement operation. How the circuit will act like a decrement operation. Before that, just we'll see how to perform a decrement operation. Decrement means just subtracting a 1 from the content of the register. Subtracting a 1 from the content of the register. When you are, I already told you that when you are using this subtraction, you will always implement this subtraction instead of direct subtraction. You will use addition with complement. You will use the addition with complement. In that way, you can implement the subtraction. So to implement the subtraction, first you need to know the ones complement and twos complement. The twos complement should be added. Therefore, it will give you a subtracted value. Here, what is to be subtracted? 1. The subtracted value is equal to 1. So you need to get the twos complement of 1. 3 zeros and 1 by third. A register is having 4 bit. So what is the ones complement for this? 311 How to get the twos complement? To the ones complement, if you add a 1, you will get a twos complement. So to this 311 if you add a 1, you will get all 4 1. That means to perform a decrement operation, you need to add this all 4 ones to the content of the register. Whatever the register it is, it can be R1, R2 or whatever the register it is. So to perform this 1101 minus 1, you can perform using twos complemented addition. So what is the twos complement of 1? It is 4 1. So 1101 should be added with 4 1, which will give you this 11. Now when you are to implement this decrement operation using the hardware components of the register, you always need to add 4 ones to the content of A. 4 ones plus 0, because the output function is D equal to A plus Y plus Cn. So here the carry input is 0 is equal to 0, and to this Y you need to have 4 1. What is Y? Y is the output of the multiplexer. Go to the logic circuit. Y is the output of the multiplexer. Your Y should be equivalent to what? 1 1 1 1. That means which input line of the multiplexer is connected to 1? The third input line is connected to 1. So if you select the third input line, your output will be Y. The Y value will be equal to 1. How to select this third input line? The selection of an input line is dependent based on the selection values, right? Therefore, to select this third input line, values of S1, S0 should be equivalent to 1, 1. The decimal value of 1, 1 is equivalent to 3. So, you need to select S1 and S0 as 1, 1 and S1 and S0 as 1, 1 and Cin as 0. Then you can have the logic circuit acts like a decrement operator. D equal to A plus Y you will get. A plus Y plus 0. C, because Cn you are selecting as a 0. In that way, based on the different combination of the selection lines and your carry input, the logic circuit will perform different arithmetic micro operations. Is it clear? This is about your arithmetic micro operations. If you are clear with this, in the next session we'll start logic micro operations. Shall I stop the session for today? Is it clear, Ma? Is everyone understand? If you still have any doubts, you just send every section is having a CRs group, no? In that CRs group, you just post the doubts, whatever you are having. We are there to clarify your doubts. If this time is not sufficient, if the time is not sufficient, you can just call us. You can call your corresponding teachers, or you can post the questions in the WhatsApp group. We will help you. We will send the PPTs. I think I already sent these PPTs in the last session itself. Okay, Ma, I'm going to end my session for today and we'll start the quiz. Thank you.